Okay, my name is John and this is John's Science Fair project. This video series is going to be on how to use an alternator to charge a battery in your house without it being connected to your car. This is not an adaptation of perpetual power. I've seen a lot of those videos where they take a rope, wrap it around the alternator after they connected it to an electric motor with a V-belt, and they get it spinning and it produces enough power to power an AC motor, and the AC motor keeps the alternator spinning. It completes like an infinite loop. The problem with that is they took the alternator and hooked it straight to the motor. They put magnets inside it, trying to show people that you can use the magnets inside of an alternator to change it from a DC alternator to an AC alternator, and putting out at 230 volt and running a 220 AC electric motor and having enough voltage left over or amps left over to run a European power strip where you could plug in 230, 220 volt appliances and run them straight off it as if you're in Europe. It's a good in theory, but a lot of people don't believe it can be done. The battery or the magnets cost a ton, so it's not very feasible. This here is nothing like that. I'm going to be using a DC motor with an alternator, and we're going to get that spinning to charge up batteries, and we're going to hook an inverter to it and plug in appliances. Now, where I'm going with this and everything else will be apparent, but first thing we have to do is prove this can be done. So bear with me, and we're gonna make a prototype. Once the prototype is done, you can see for yourself, and I can go through step by step. And as we do this, I'll explain what it is I'm using and how we're doing this. So bear with me. All right, what we're gonna use for our motor is this here, okay? I already took it apart. This part right here is usually slid all the way back into here. This is a blower motor out of a 2006 Dodge Dakota. We're keeping this part so we have something to mount with. We're gonna use this part after we take the bird cage off to take and power our pulley and power the alternator. This here will spin clockwise and counterclockwise. And as you can see, it's old. We can take this time now while we have it out to clean this up. The cleaner it is, the more efficient it will run. All right, for now, I'm gonna stop the video. Once I got this here cleaned up, I'll come back and show you the end product. All right, this is our DC motor. It had this on it. What I did was, I took a flat tip screwdriver and a hammer, hit right here on the edge. As you can see, it cracked it. So I just use the hammer on the bottom side and pound it on here. So I was going down like this, and it came right off. I don't know if you can see up in there, but everything looks all shiny still. It's the way copper's supposed to look. All I'm using is a can of compressed air and paper towel I use to wipe the whole front end of this and the whole body off to get as much carbon off and out as we can. Use a sanding block and go nice and gently, just like this, back and forth on the contacts to clean it up like so. Make them kind of nice and shiny. Just remember, this is for a prototype. This is not a permanent thing. Soon as whether we decide to keep using this motor or not, we'll determine whether or not this becomes permanent. Now, we are going to use a couple of shims. I got to put one inside of the other to fit inside of this to adapt that hole down to this here. Now keep in mind, this is just stuff I'm trying to use at home to save some money without having to go out and buy all sorts of shit, okay? Thank you for your understanding. All right, as soon as I got this adapted onto this, as soon as I got these here combined, I will take and be right back and I will tell you what I did. That way you don't hear all the pounding and everything and you can see the finished product before it starts being used. All right. I am back here. This is our motor. It's the same DC motor we had earlier. I took and put the metal shim on here, and I put the pulley over the top of it, and as you can see, there's a set screw right there inside of the pulley shaft, or inside of the pulley, so we could tighten it down to the shim that we put on. I couldn't get the shim to go all the way on, but this is a prototype, so it's not meant to be perfect. It's meant to just serve a purpose. As you can see, this thing is wobbly. It is not straight. I was afraid that if I pounded on the shim too much, that it wouldn't, afraid that if I pounded on the end of the shim too much, that this shaft right here would have got jammed up in the bearings here and back here. And last thing I wanted to do was ruin the motor. So for right now, this will serve our purpose. It's stiff. It's not going to go anywhere. I can't just pull it off. It's not going to come flying off. So it is set where we can work with it. Now, if it comes out that I want to keep this here set up like this, then I may just take and pull the shim back off, drill it out a little bit, just so that the center's a little bit wider than what it is, and get it on there. Now, in case you're wondering, what did I use to figure out what size shaft I needed to go with this? I measured it with what's called a micrometer. Take the outside diameter of the shaft and the inside diameter of the pulley you want to use, and then I went to Home Depot and I bought a shim. That's what this little silver metal thing is. It's a shim. It's a steel shim, so it would hold up to this. I had a plastic insert to go inside just in case my measurements were off, but the thing's a bit thicker than I thought it was. So we have this all set up. We got our contacts, we got them all cleaned up and stuff. The only other problem I ran into is I started melting my power leads to see if this thing would spin. So I made new ones, and let's see what I had to do. All right. Alright, this is the battery I'm wanting to use. Right now, on the red and the black, I have my power supply hooked up to it. As you can see, it's on right now and it says the battery has an error. So, we already knew starting this that was a bad battery. Our motor is a 12 volt motor. So, I hook up the multimeter, set it to DC voltage. We've only got 9.14 volt and dropping. That is one of the key indicators of a bad battery. Charge it up. Charger says it doesn't want to charge it completely, and it'll charge it what it can. You put a multimeter to it and hold it like I am, and your voltage drop without any load on it. It just drops. I mean, I can unplug everything, but I know this is not putting a draw on it. These wires are the other ends of the black ones that are on there, and they're not connected to anything. These are the ends that we're going to be connecting to our DC motor. So this here, as you can tell, it's still dropping. But for shits and giggles, let's take and hook up these here. Now, this is all makeshift, so please don't judge me. And if you don't know what you're doing, get somebody that does, so you don't kill yourself. Because you may not kill yourself with DC voltage, but later on, if you're not comfortable with DC voltage, we're going to be moving on to AC voltage. And AC voltage can kill you. All right, now as you can tell, I'm not holding the metal. We just got it all set right there. I have the other ends up there with the multimeter ends. And we've got the multimeter right there, so we can monitor the voltage as we tap the connector. So let's see here. As you can tell, we had enough to make the pulley jump a little, but it's already down to 4.5 and rapidly dropping. Take the contact away, and the voltage stops dropping and goes back up some, but it's still not where it needs to be. It needs to be up at around 12 volts. But as you can tell, that there kind of battery will turn this pulley eventually. All right, I have 3 bad batteries. What I'm gonna do is I'm gonna hook them all up in parallel and hit them with the charger, and we'll see if we can get enough juice to really spin this alternator over, or this blower motor over. Okay, I got these all hooked up in parallel. The way you know you got it in parallel is you got my red positive jumper cable on the positive one there. Went to the yellow top. I hooked the same red one to the positive on the yellow top. Then I hooked another red jumper cable to it. I know it looks a little like dingy red, but it's supposed to be red. And went to the positive on the Titan battery with this with the opposite one. Did the same thing, as you can tell by looking at the wire and at the clamp, the same thing with the negatives. Now, I am betting some of you that are electricians out there are like, why did he hook them in parallel and not series? Well, series is made for maintaining your voltage through all of your batteries and helping to and upping your amperage. Parallel is supposed to help you maintain your amperage but increase your voltage. So what we're looking at doing is trying to create 12 volts amongst bad batteries. So you have to keep in mind what it is you're trying to do. If you're trying to accomplish upping voltage, you need to do the one that's for that. As you can tell, we got 8.13 volts on that one, and we've got 8.14 volts on that one, and 8 volts on that one. All right, now they're all linked up in parallel, but I just gave you the amperage or the voltage of each one as a single battery. Now, what we're gonna do is we put our positive up here, and then take our negative, come down here, still at 7. But if you remember, this one was a lot less than 8, and it's still somewhat climbing. But because the multimeter is making a connection, you know that we have some form of continuity because we got the multimeter leads on 2 different batteries. So we know there's a roundabout connection. All right, so what I'm gonna do is I'm gonna hook these things up to charge. Now, when you do this, you wanna take your positive and put it on one battery, and then take your negative and go to the battery furthest away. You want to put it on the negative of the last battery. This is the best way to charge batteries when they're in parallel. Come on. All right, and as you can tell on our charger, we got the little dot dashes and the lights aren't blinking, and you got the lines going all the way through to the battery on there. We're gonna hit the charge button, and as you can tell, it's starting to charge it up, and it's already up to 12.5 amps. So hopefully here in a few minutes when it's done, I can show you and we can see if what kind of voltage we got. Maybe we'll be able to spin this motor over. All right, I'll get back to you in a minute. All right, I'm back, and you can see our vector charger. The battery's flashing on it. It's got a little triangle in the middle between the lead pieces, which means that it has a problem. But like I said, these are bad batteries. There's gonna be a problem. And yes, I am using bad batteries on purpose. So we're gonna take and hook up our multimeter. And as you can see on our multimeter, we're up to 10 volts and slightly dropping. See, 10.14, 10, 10.3. But it's still higher than the 8 or 9 we were working with. So let's just, for shits and giggles, see what we get. Put our multimeter down here where we can see it. Put our multimeter lead back up here, making its loose connection. See if we can make a little better connection. All right, now we want to take our leads here. Come on. All right, we're gonna take one lead. We're gonna hook it up on here for the positive. I'm gonna hook there. Take you. We're gonna hook it to one side on this. And as you can tell, multimeter's still dropping. I do not have any hope that this will power the motor as is. I mean, even if I turn on the charger piece, it might not work very well. Let's see here. Do we end up with it moving? Multimeter dropped like crazy, but no, it's just too much draw between the batteries, and we've just dropped way too much voltage. So, to answer your guys' questions of can we use bad batteries to do this? As you can see, no, you can't. And if you could fix bad batteries, this would have done it, all right? There's all these things out there about balancing batteries and being able to do different things with your batteries. And they are possible, they are right. But your testing is only gonna be as good as the equipment that you're using. So for this science fair project so far, we need to acquire a good battery. So next time I see you, I will have probably my motor mounted, the battery out of my pickup truck, and hopefully we can get the alternator mounted. And we're gonna use that piece of wood down there to mount them to. So hopefully we can get this all to work right. All right, talk to you guys later. Bye. All right, people, this is John again, and we are out here with the truck. I was curious as to whether or not our little motor here would actually turn over with a good 12-volt battery. So, took our little cables, we clipped them on just like we normally would, and we're gonna take our little motor and we're gonna hook our cables to it. Now, that's how we got one, and this is the other part I didn't plan out. I never said I was totally intelligent, so bear with me. So as you can see, with a good battery hooked up, we have wobble, and the motor does make some noise, and that is quite a bit of wobble for what we want to do with it. But with a better DC motor, I think this one's on its last legs, which is why I took it out of the pickup truck and replaced it with a different one. But this will definitely work. It will show you how to actually do this up. For now. Alright, I took you guys outside and showed you how we could take our little cables that we had, hook them up, and the motor works and the pulley spins. Just off the battery. If you note, there was no background noise from the truck at all. It was off, the key was hanging up. So now we know that will spin. We also know that the 10 gauge wire that I was using with the little clips I put on it, the clips are just too small and they were heating up, and the cable itself was probably about the right size. It's just the clips on the end were the wrong size. The problem is the amount of voltage required for that battery to that motor versus the durability or the power allotment for the parts that I was using. Like I said, this is for a prototype, and this is just to show proof of concept. So before we move on to making a final product, we're gonna have to make a note to replace those cables and those clips with higher gauge clips or higher gauge cable, depends. We can go to a clip that match the wire and find out that the whole wire heats up. So we are definitely gonna make a note of it, and it's one of the things we'll change after we've reached proof of concept. But for safety's sake, don't try holding a phone, hooking up clips, and holding a spinning motor, because it can spark. Just like you saw the I tried showing you how the motor was spinning and everything else, and one clip slipped, tapped the other clip, and it caused a small spot weld on my battery, or on the clamp for the battery terminal. Nothing major, just be careful and learn from my mistake. If nothing else, learn from my mistake. You'll save yourself a lot of pain, a lot of problems. And if you want to write in a comment that I was stupid, go ahead. I don't care. All right. Okay. This here motor, I went ahead and put it back in its housing. As you can tell, I did that for mounting purposes. Now, this here, what I noticed was on the inside here, there's no break in between the two pins. So I took that into account when I took and put the new ends, like I said I was gonna, on the cable. What I did was I found some cable ends. They're like $5 at the auto parts store to put these kinds of clips on it. These slide right on the pins on the back of the motor. And I'll show you how here in a second. You just take them, make sure you face them away from one another, just so that you have as much play from one to the next. See, they just slide right on there and they'll hold themselves right in place. Makes it real nice because they slide right in. They don't fall out very easily. So it's all good for the cables. They are also the higher end clips for the wire, so hopefully they don't heat up this time. Now we're gonna assemble our prototype. I've got my motor right there, I got my alternator, and I've got my mounting bar and my other stuff that I'm gonna need to do this with. Here's our other mounting bar, and there's the belt. I also went and picked up the replacement battery for my Miata that I needed to get anyway. So now we have a good battery instead of a bunch of bad batteries to play with. Alright, now to assemble this thing and see what we come up with. Now just remember, this is just a proof of concept. So it doesn't have to look pretty. It just has to show that the idea is sound and that it could work. That's all. Take our makeshift board here, grab our screw, going right through the original mounting holes for the bracket. I'm gonna take and get it started. I'm gonna take this screw and go right through here. Now, some of you might be asking, why use the board? Why make an adapter? Or why do you use this or that? Like I said, this isn't permanent. Once we decide that this works and that we can work with it, as we replace parts, we will improve the mounting system and we will improve on the parts that we use. Just plain and simple. Now this here's our alternator we're gonna use, brand new. I went to the hardware store and I found a nut, or not a nut, but a bolt that I'll thread right into this ear on the alternator. So we can use that ear to go ahead and bolt this thing together. And use it for mounting. Alright, here's our handy ratchet. Put the bad boy down. Okay, I did tighten it down so that it would stay up straight, but I have a way we can take and put some slack into it, just a little bit. The reason we're gonna need it is so that we can put the belt on. So we have a little bit of play in it so that it'll hold itself still, but we can manipulate its motion to put the belt on. And then we tighten it down for good. Now, for the motor, you can take and turn it up just like this. Like I said, we're gonna use this bar to mount to the mount with. So how far apart do we need this? Well, one way to tell. Take and hold this up here like this. We can take this here, put it go like this. You got a general idea, go up almost where we want it, because it gets kind of tight right there, and yeah, we still got some room where we can tighten it down even more. So I think that's a good spot for it. So we can turn this back, pull this off, make sure we have our bar lined up the way we want it. All right, now we take a screw. Oh, my other screw. Then take the screw, we can put it right here so that we have it set on the edge so it can't, with the belt, when we put tension on it this way to tighten this down, it can't pull our motor closer. It actually makes the belt tighter and it can't pull this to it. Now, I do have another screw in here that I left in. It's right here. And what that does is it stops the lateral movement going other way. So if that thing starts to wobble, it really can't dance off of this bar. All right, now we have the motor and the alternator connected. And I have a box of handy dandy screws right here. All right, now what I'm doing with the battery is I'm setting it on my angle iron down here. I'm setting it right on the angle iron so that this here doesn't twist when it's running. We're just gonna use the battery as a point of bracing to keep everything upright so we can do this. Now, we have our thing for our prototype. This is what we're gonna use for proof of concept, how we can mount it and get to it. All you have to have common sense, a little bit of ingenuity, and a little bit of want to challenge yourself. Probably should have done this part first. Alright, as you can see, we have the whole thing pretty much put together. Now, I'm going to take and pull this off, and we're going to connect a pair of jumper cables to the back of this. what we're looking at connecting to is right here, there's a red cap, and right here there's a black one. What those two are for is the power and ground for completing the circuit on this here setup. And what that does is it's how it puts power to the battery. Now this alternator is rated to put out regularly 65 amps of power. What we're looking for is it to at least provide some power going to the battery. So what we're gonna do is we're gonna leave one set of the cables out here. We're gonna take the other set of the cables and we're going to hook them to the back of the alternator. This way, when I hook up the motor to it, you can tell, I can show you on the multimeter that the alternator is actually putting power out separate from the battery. See, where's the multimeter? All right, we got our handy dandy multimeter right here. Okay, so I'm gonna get a different set of test leads. These here, it's just a wires with gator clips on the end of them. So I got one that's red and one that's black. So I can make this real easy. Red to red, black to black. Turn on the multimeter, connect this red one to this here jumper cable. Like I said, red to red, black to black. And as you can see right now, the multimeter is putting out a big fat 0 because it's not turning. So time to hook up our leads. Now, those of you that are trying to recreate this at home, you have to pay attention to your leads and which way your motor turns. Because if you've got only 2 wires, your motor can turn clockwise. Your motor may be able to turn clockwise or counterclockwise. If it can only turn one way, if you hook them up backwards, it'll just smoke. It won't really even turn. Okay, break it. Let's see if we got any power for the motor. I hope my test earlier I didn't take and burn up my motor. Is that there? Yeah, we've got 12 volts. Let's see here, just out of curiosity, if I was to go like this and go like this, I can't even get it to the right RPM. All right, well, we're at a standstill for the moment because I guess I fried the DC motor earlier. Let me figure this part out and I'll get right back to you. Okay, I did a little bit of investigation into what happened. I ran a test with the whole system earlier so I know it worked. But, like I said, this is for a prototype and proof of concept. I'm putting this video out just to tell you guys that it did work. The alternator wasn't running at peak capacity. I mean, it wasn't even putting out the full 14 volts that it should have been putting out to the battery. But the blower motor was turning it. And it went for like a good 15-20 minutes. And what I think happened is because of how old the blower motor is, it started to overheat because it wasn't meant to run at peak speed for like 15 to 20 minutes straight. So I'm gonna have to get another DC motor. I'm looking at a couple of concepts online, or a couple of ideas online. And when I put out my next video here in about a week, I'll have another motor, and hopefully I can find one that's got a bit better of a power capacity to it. But this idea does work. It worked. The way I know it worked is because it works in cars. You have your gasoline engine, your alternator, and your battery. Your battery is used to initially start the gasoline engine. Your gasoline engine is used to turn the alternator, and your alternator puts out 14 volts, 12 volts to run the car and all your accessories in, and 2 volts to charge the battery. It's not a bad concept, and it's not a bad way for it to work. When the car is at idle, the amps in the alternator get picked up by the alternator, and it pushes out a little bit harder to the battery to charge up the amperage and stuff in the battery, and to help the battery charge as fast as it can when the vehicle's not under as much of a power load. That 12 volts that the vehicle uses is not necessarily dedicated to the vehicle, but it is prioritized and available to the vehicle. The vehicle or your car will not use more than the 12 volts out of your single battery. If there is, you've got a short somewhere in your car. But this is not an automotive diagnostic for your alternator or anything like that. This is my science fair project. And like any other project, things go wrong. But they use a similar concept in a lot of your Class B vans or your van houses or whatnot. They use the alternator from the engine to go through a couple of controllers to charge up your battery for your car or for the van motor itself, and the house batteries for the RV section of the van with all your 12 volt accessories and all that stuff. And it runs off of an inverter. Well, on this video, we didn't make it to the inverter. I regret that part, but things happen. And I will be getting a better motor because I know this works. I know it's going to power my house. Maybe not this alternator, but the series of things to do is we want to take and prove that it worked. Then we want to take all the parts and improve on them. So I used a blower motor. Matter of fact, it was a blower motor I pulled out of a 2006 Dodge Dakota because I thought it was bad. And it just shows that it was intermittent. It was essentially a bad motor. So I just used it and it just blew on me here. All this stuff happens. I'm using a new alternator just because the 400 amp alternator I was using in a truck to have put in as a second alternator and to power a bunch of other accessories that I had in my RV or in the fifth wheel that I was pulling. I was trying to charge up the battery and stuff. Well, the people that installed it put substandard equipment in to handle the charge for a high output alternator. So consequently, my charger melted down. And after looking at my alternator, it don't look very good. So I went back and did what I should have done in the beginning. I should have checked all my sources and researched the people that were doing that level of installation, dealing with that kind of stuff on a high value item. And I didn't. So this is me making up for that. I am going to replace that alternator and I am going to upgrade the DC motor. I was thinking about going to an AC motor. I don't know. But I'm thinking a DC motor makes a bit more sense to me. Some of the things that we're going to be doing on this video is we're going to be introducing a bunch of Victron parts. Okay? Victron Energy has made it their business and profession to make parts for DC to DC charging, which is using an alternator to charge batteries, and for using solar panels to charge batteries, and helping to size battery banks to power houses and to power RVs. Now, one of the things that really got me thinking about this is there's a guy that had 20 solar panels on top of his fifth wheel, and he was putting out enough power on a bad sun day to power not only his RV, but the RV next to him, and then the one that was next to it. So he was powering 3 RVs off of a 20 solar panel setup. His solar panels were at 490 watts per panel. Now, just to break it down, that's 20 at 500, makes it easy math. So 20 at 500, that's 10 at, it's about 10 panels at 1,000 watts each for the setup. So he was putting out 10,000 watts of power, and that equates out to what? What was it? It was 10,000 watts divided by 12 volts. That was about 819 amps. Is that what he was using? I was looking at doing this with a 400 amp alternator. Differences between the two. If I could get the alternator to run at peak power all the time, or when it was needed to charge the batteries, it would put out 400 amps, which is about half the wattage that guy was putting out of 20 solar panels. So it equates out to about 5,000 watts of power. Victron has made it their business of, like I said, controlling the power for DC to DC charging and for solar panels to charging batteries. And then they have awesome inverters and chargers to upgrade the stuff in your RV from what the manufacturer puts in to something that will adequately or more than adequate power your RV. Not saying that the RV companies did a bad job, but when they do things, they make the same ones. It's like a cookie cutter routine thing. So when you finally get one, if you ever decide to buy one, you may find that it has some Victron Energy parts in it. It may not, but just like anything else, you have to take it, buy it, and then make it your own. And that's what people with solar panels have done, and people with these vans have done, adding bigger battery banks, changing out parts from factory parts to other well-known company parts, trying to find what works best for the application that helps them meet what they want. And in the end, that's what this is. I mean, you can buy a cookie cutter house and there's always going to be something you want to change. Or maybe you want a different AC system because the one that's there's something about it that irritates you. Some people like having options. Some people like having everything laid out for them. So this video is to go through and show you all the different things that you can do with this kind of a setup. It's very versatile. Let alone the guy that had 20 solar panels could only work at maximum capacity during the heat of the day, in the middle of the day, in full sun, with all of his panels putting out at 100%. Now his battery bank was enough to power his whole entire RV plus 2 more through the night. There's no sun at night. So I'm willing to bet that if I could put out half the power that he had and cut the battery bank in half, I could power my own stuff and be just fine. But that's what we're doing this to find out. And if what I'm saying is intriguing to you, great. Please subscribe to this. I would like to keep it going. Well, I'm gonna keep it going whether you do or not, but subscribing and getting as many hits as I can on it lets me know that the information is getting around and people like what it is I'm saying. Please leave comments. I'm not perfect. Maybe you're an electrical engineer. I'm not. I'm just good with my hand and I'm good at researching things. And I know that this here has been used in a lot of different things, like cars, RVs, similar concepts being used in EV cars today. They use similar things on boats. And so I'm just showing one option for one type of application right now. And then we're going to move to another application. And then we're going to try another application. If there's something you want to have powered and you want to know if this could power, ask. With the way this is, I could probably take and build it all up. If you like what you see, great. Ask me. I'll be providing links in the bottom for where I get some of the part. But if there's parts that you can't find or you just are unsure about, let me know. I can look them up. I'll need no specifics about your application, but we can email back and forth. I can get that, and I can get you the information. And that's what this is all about. Just putting out the information and letting people know that not everything is bogus. Like the perpetual power thing. That wasn't necessarily bogus, just people didn't understand how to do it. Let alone if you don't have an electrical engineer degree, you're not going to know exactly how many batteries of what type of metal and how strong they have to be and how to orient them. It's not something the common Joe can do. What I am doing takes a little bit of hands-on ingenuity and thinking, but most of the major parts I'm not building myself. I'm getting them from other places. So trust people a bit. Not everybody's out there to screw people over, and not everybody puts out bad information. And my idea is to keep this thing low-key enough to where anybody can do it. And I'm starting to ramble, and I can take this so many different directions right now, but I'm not going to waste your time. Thank you for your time, and bye for today. Look in about another week for another video.